This research paper, titled Memorization: A Close Look at Books, was authored by Iris Ma, Ian Domingo, Alberto Crona Martins, Pierre Baldi, and Cristina V. Lopez from the University of California, Irvine. It explores how large language models, or LLMs, can memorize and potentially regurgitate entire books from their training data. The study focuses on the Llama 370B family of models and uses a technique called prefix-prompting to test this capability. The core question is, to what extent can entire books be extracted from these models? The researchers found that by providing just the first 500 tokens of a book, they could auto-regressively reconstruct Alice's Adventures in Wonderland with a very high level of similarity. This means the model generated the rest of the book step by step, closely matching the original text. They also achieved high extraction rates for several other books, though not always in a single auto-regressive pass. Instead, they did it piece by piece. However, not all books were equally easy to extract. The success rate correlated strongly with the book's popularity, which likely stems from how often the book appeared in the training data. For instance, more popular books, as measured by the number of ratings on Goodreads, were more likely to be memorized due to duplication in the datasets used to train these models. The paper also delves into the mitigations designed to prevent this kind of regurgitation. Companies developing LLMs often use strategies like data deduplication, content filtering, alignment techniques, and output validation to stop models from spitting out verbatim text. These are meant to protect against privacy risks, such as leaking sensitive information, and to avoid legal issues related to copyrighted material, like books. Despite these efforts, the researchers confirmed findings from recent work by Nasr and colleagues in 2025, showing that these mitigations can be undone in the instruction-tuned version of Llama 3.1. Specifically, they used a fine-tuning-based extraction technique to bypass these safeguards. This means that even after alignment processes, which fine-tune models to follow instructions and behave safely, the models still retain memorized content that can be accessed. To understand this better, the team analyzed how fine-tuning affects the model's weights. They discovered that the undoing of mitigations involves changes to only a tiny fraction of the model's weights, and these changes are concentrated mainly in the lower layers of the transformer architecture. This provides insight into how alignment alters the model's behavior without completely erasing memorized information. In their experiments, the researchers tested memorization across 9 books from Project Gutenberg using 3 versions of the Llama models: the original Llama 3 pre-trained model, Llama 3.1 pre-trained, and Llama 3.1 instruction-tuned. With the Llama 3 pre-trained model, they successfully auto-regressively generated an entire book. For Llama 3.1 pre-trained, they got high piecewise reconstruction rates for the 9 books. When comparing these results to Goodreads ratings, they found that books with more ratings, indicating higher popularity and likely more duplication in training data, had higher extraction rates. This work highlights the limits of current regurgitation mitigation strategies. Even with advanced techniques, LLMs can still be vulnerable to extraction attacks, especially for long, unique texts like books, which are central to ongoing copyright lawsuits. For example, the paper references cases where authors are suing companies like OpenAI and Microsoft over the use of copyrighted books in training data. The researchers introduce a framework for studying how fine-tuning impacts the retrieval of verbatim memorization in aligned LLMs. This framework could help in future efforts to improve model safety and reduce risks. By examining piecewise reconstruction rates and correlating them with factors like data duplication, the study offers a deeper understanding of how and why memorization occurs in these models. Overall, these findings underscore that as LLMs grow in scale and capability, the challenges of managing memorized content become more complex. The ability to extract entire books not only raises ethical and legal concerns but also prompts the need for more robust defenses in model development. This research contributes to the broader conversation on AI safety, privacy, and the responsible use of training data.